Hello students, welcome to Breedmark Academy. Myself L.S. Nanda. Now in today's video, I am going to discuss the solutions of two mathematics questions that were asked in recently held JEE Advanced 2025 Paper 2 exam. Now this is the first question of this video. This question is based on the topic of matrices and determinants. It says, let I equal to identity matrix containing the elements 1 and 0 in the first row and 0 and 1 in the second row, and P equal to a 2 by 2 order matrix containing 2 and 0 in the first row and 0 and 3 in the second row. Let Q equal to again a 2 by 2 order matrix containing x and y in the first row and z and 4 in the second row. For some non-zero real numbers x, y and z for which there is a 2 by 2 matrix R with all entries being non-zero real numbers such that QR equal to RP, then which of the following statements is R true? The first option is the determinant of Q minus 2i is 0. The second option is the determinant of Q minus 6i is 12. The third option is the determinant of Q minus 3i is 15, and the last option is y into z is equal to 2. Now students, to solve this problem, I will start with the given equation, that is QR equal to RP. Now it is given that R is a 2 by 2 order matrix, but its elements are not known to us. So I will suppose R equal to A and B in the first row and C and D in the second row. And it is given that these variables A, B, C and D are non-zero real numbers. Now students, we move further. Now students, since QR is equal to RP, so now we will find the product of these matrices. Now the matrix Q is x and y in the first row and z and 4 in the second row. Matrix R has A and B in the first row and C and D in the second row. And the matrix P has the elements as 2 and 0 in the first row and 0 and 3 in the second row. Now students, by using row by column method, we will find the product of these matrices on both the sides of the equation. So now it becomes AX plus CY, then BX plus DY in the first row, and in the second row it becomes AZ plus 4C, then BZ plus 4D. And on the right hand side we get 2A, then 3B, then 2C, then 3D. Now students, since both of these matrices are equal, so obviously their corresponding elements must also be equal to each other. Now if I compare this element with this element, I get a equation, and it is AZ plus 4C equal to 2C. This means AZ is equal to minus 2C. Now this is the first equation. Now similarly, if I compare these two elements, I get BZ plus 4D equal to 3D. This means BZ is equal to minus D. I am calling this as equation number 2. Right? Now similarly, the third equation we can get by comparing these elements, and we get AX plus CY equal to 2A. I am calling this as third equation. And then fourth equation we can get by comparing these two elements, and from here we get BX plus DY equal to 3B. I am calling this as equation number 4. Now students, we move further. Now students, since A, B, C, D, X, Y and Z, all of them are non-zero real numbers, so I can divide equation 2 by equation 1. When I do this, I get BZ upon AZ equal to minus D upon minus 2C. Now from here, I can write B upon A equal to D upon 2C. I can put both of them equal to a constant K. Now from here I get B equal to AK and D equal to 2CK. Now students, I will put B equal to AK and D equal to 2CK in equation number 4. Now equation number 4 is Bx plus dy equal to 3b. So now it will become ak into x plus 2ck into y equal to 3ak. Now students, clearly k gets cancelled on both sides and we get ax plus 2cy equal to 3a. I am calling this as equation number 5. We already have equation number 3 as ax plus cy equal to 2a. Now students, just subtract equation 3 from equation 5. So when you subtract equation 3 from equation 5, you will get cy equal to a. That means from here I can write y equal to a upon c. Now students, from equation number 1, I already have z equal to minus 2c upon a. So if I just multiply both y and z, I get minus 2 into c upon a into a upon c, which is nothing but just equal to minus 2. So that means y into z is equal to minus 2. So this means option D is not correct. Now students, we move further. Now students, I will put cy equal to a in equation number 3. So from here I get ax plus, in place of cy I will put a, and this is equal to 2a. So from here I get ax equal to a. Now since a is a non-zero real number, so I can cancel a on both the sides of this equation to get x equal to 1. Now students, we have got the value of x as 1. Now we move towards the first option. First option says the determinant of q minus 2i is 0. Now the matrix q minus 2i is equal to, now q has the elements x and y in the first row and z and 4 in the second row, and in place of x we can write 1. So now it becomes 1 and y in the first row and z and 4 in the second row. And then we have 2i, which has the elements 2 and 0 in the first row and 0 and 2 in the second row. Now students, the matrix q minus 2i becomes minus 1 and y in the first row and z and 2 in the second row. Now clearly I can write the determinant of q minus 2i equal to minus 2 minus yz. Now students, we have already found the value of yz as minus 2. So now it becomes minus 2 plus 2, which is equal to 0. That means option A is the correct one. But since it's a multiple correct question, so we will have to check other options also. Now we move further. Now students, option B says the determinant of q minus 6i is 12. Now let's find the matrix q minus 6i. Now q has the elements 1 and y in the first row and then z and 4 in the second row, and 6i has the elements 6 and 0 in the first row and 0 and 6 in the second row. So now q minus 6i will have the elements minus 5 and y in the first row, and then z and minus 2 in the second. Now students, determinant of q minus 6i becomes equal to 10 minus yz, and since the value of yz is minus 2, so 10 minus yz becomes equal to 12. So that means option B is also correct. Now students, we consider option C. Now option C says the determinant of q minus 3i is 15. Now let's find the matrix q minus 3i. Now matrix q minus 3i will have the elements minus 2 and y in the first row, and in the second row elements are z and 1. Now students, the determinant of q minus 3i becomes equal to minus 2 minus yz. Now since the value of yz is minus 2, so clearly minus 2 minus yz becomes equal to 0. That means option C is not correct. So finally we conclude that option A and B are correct for this question. Now students, we move towards the next question. Now students, this is the next question. It's a very good problem based on the concepts of coordinate geometry and area enclosed between the curves. It says, let S denote the locus of the midpoints of those chords of the parabola y square equal to x, such that the area of the region enclosed between the parabola and the chord is 4 upon 3. Let R denote the region lying in the first quadrant enclosed by the parabola y square equal to x, the curve S, and the lines x equal to 1 and x equal to 4. Then which of the following statements is R true? The first option is 4 upon root 3 belongs to S. The second option is 5 comma root 2 belongs to S. The third option is area of R is 14 upon 3 minus 2 root 3. And the last option is area of R is 14 upon 3 minus root 3. Now students, let's solve this question. Now students, to solve this problem, first of all, we will have to find the equation of the curve S. Now curve S is the locus of midpoints of all those chords of the parabola y square equal to x that enclose an area of 4 upon 3 square units with the parabola. Now in the figure you can see I have drawn one such chord AB. Its midpoint I have taken as the point C H comma K. Basically in this question we have to find the locus of the point H comma K. Now to find the equation of the curve S, we will find the area enclosed between the parabola and the chord and put it equal to 4 upon 3. But for that purpose, we need the equation of the line AB. Now students, since C H comma K is the midpoint of the chord AB, and we know that for a parabola y square equal to 4ax, if h comma k is the midpoint of its chord, then the equation of the chord is given by ky minus 2a into inside the bracket x plus h equal to k square minus 4ah. Now for this parabola, the equation of chord AB can be written as ky minus 1 upon 2 into inside the bracket x plus h equal to k square minus h. Now This further becomes ky equal to 1 upon 2 into inside the bracket x plus h plus k square minus h. If I divide both sides of this equation by k, it becomes 1 upon 2k into inside the bracket x plus h plus k minus h upon k. Now this can further be written as y equal to x upon 2k plus k minus h upon 2k. Now finally I can write the equation as y equal to 1 upon 2k into inside the bracket x minus h bracket close plus k. Now students, we move further. Now students, to find the area of the region enclosed between the parabola and the chord AB, I have taken the coordinates of the point B as t1 square comma t1 since it is lying on the parabola y square equal to x, and the coordinates of the point A as t2 square comma t2. Now the point C h comma k is the midpoint of the chord AB. So by using midpoint formula, I can write t1 square plus t2 square equal to 2h and t1 plus t2 equal to 2k. Right? Now students, to find the area enclosed between the parabola and the chord AB, we will have to find the values of x in terms of y, both from the parabola and the chord AB. Now, the area enclosed between the parabola and the chord AB is given by integral t1 to t2. X obtained from chord AB is given by 2k into inside the bracket y minus k bracket close plus h minus x obtained from the parabola is y square into dy, and the value of this area is given to us as 4 upon 3. Now the left side of this equation can further be written as 2k into y square upon 2, which becomes ky square minus y cube upon 3 plus h minus 2k square into y, and the limits are from t1 to t2, and this value is 4 upon 3. Now students, it can further be written as k into inside the bracket t2 square minus t1 square minus 1 upon 3 into t2 cube minus t1 cube plus h minus 2k square into t2 minus t1 equal to 4 upon 3. Now students, we move further. Now students, take out t2 minus t1 common from the left hand side of the equation. Now it becomes t2 minus t1 inside the bracket into inside another bracket k into t2 plus t1 minus 1 upon 3 into inside the bracket t1 square plus t2 square plus t1 t2 bracket close plus h minus 2k square bigger bracket closed equal to 4 upon 3. Now students, we know that t1 plus t2 is equal to 2k. t1 square plus t2 square is equal to 2h. But we do not know the value of t1 t2 in terms of h and k. So now we will find the value of t1 t2 in terms of h and k. Now t1 t2 can be written as t1 plus t2 whole square minus inside the bracket t1 square plus t2 square whole divided upon 2. So that means t1 t2 becomes equal to, now t1 plus t2 is 2k, so it becomes 4k square minus t1 square plus t2 square is 2h. So the value of t1 t2 becomes equal to 2k square minus h. Right? Now students, this equation can further be written as t2 minus t1 inside the bracket into inside another bracket. It becomes k into t1 plus t2, which is nothing but 2k square minus 1 upon 3 into inside the bracket. Now it becomes 2h plus t1 t2, and t1 t2 is 2k square minus h bracket close plus h minus 2k square bigger bracket closed equal to 4 upon 3. Now students, it can further be written as t2 minus t1 inside the bracket into inside another bracket 2k square and minus 2k square get cancelled, and when we take the LCM of the denominators, it becomes minus inside the bracket 2k square plus h plus 3h outside the bracket whole divided by 3 equal to 4 upon 3. Now students, 3 get cancelled on both the sides. Now we move further. Now students, this can further be written as t2 minus t1 equal to 4 upon 2h minus 2k square, which is equal to 2 upon h minus k square. Now students, to find the locus of the point h comma k, we need to eliminate t1 and t2. And to eliminate t1 and t2, I am using a basic equation, and that is t1 plus t2 whole square minus t1 minus t2 whole square equal to 4 t1 t2. Because we know that a plus b whole square minus a minus b whole square is equal to 4ab. Now students, I know the value of t1 plus t2, which is 2k. So it becomes 4k square minus t1 minus t2 can be written as 2 upon k square minus h. So t1 minus t2 whole square becomes 4 upon k square minus h whole square. And this is further equal to 4 t1 t2. And we have just found the value of t1 t2 as 2k square minus h. Now students, this can further be written as, you can cancel out 4 throughout the equation, and now it becomes minus 1 upon k square minus h whole square equal to k square minus h. So from here I get k square minus h whole square into k square minus h, that is k square minus h whole cube equal to minus 1, or I can write h minus k square whole cube as 1, and from here I get h minus k square equal to 1, or the locus of the point h comma k can be written as y square equal to x minus 1. Now students, we have got the equation of the curve S. Now we move further. Now students, we have found the equation of the curve S as y square equal to x minus 1. Now we check the first two options. The first option says point 4 comma root 3 belongs to S. Now when I put x as 4 and y as root 3 in this equation, I get 3 equal to 3, which is correct. So this means point 4 comma root 3 belongs to S. That means option A is correct. Now second option says point 5 comma root 2 belongs to S. When I put x as 5 and y as root 2 in this equation, I get 2 equal to 4, which is clearly false. So this means point 5 comma root 2 does not belong to S. That means option B is not correct. Now students, to check the remaining two options, we have to find the area of the region R, which is lying in the first quadrant and enclosed between the parabola y square equal to x, the curve S, and the lines x equal to 1 and x equal to 4. You can see the shaded region R in the given figure. We have to find the area of this shaded region. Now students, this is given by integral 1 to 4 y of the original parabola, that is square root of x, minus y of the curve S, that is square root of x minus 1 into dx. Now this is the required area. I am calling it by the letter A. Now students, it becomes x to the power 3 by 2 divided by 3 by 2. So this is 2 by 3 into x to the power 3 by 2 minus 2 by 3 into x minus 1 to the power 3 by 2 under the limits 1 to 4. Now it becomes 2 upon 3 into inside the bracket. This is 4 to the power 3 by 2, which is 8, minus 3 to the power 3 by 2, which is 3 root 3, minus inside the bracket it is 1 minus 0. So this becomes 2 upon 3 into inside the bracket 7 minus 3 root 3. And this is finally equal to 14 upon 3 minus 2 root 3. That means option C is the correct one. Now students, finally we conclude that option A and C are both correct. Now students, this is to inform you that I have created two separate playlists of paper 1 and paper 2 for JEE Advanced 2025 math solutions. So you can go to the playlist section of my channel and watch all of these videos. Keep watching my videos and enhance your knowledge of mathematics. Thanks.